another phrase you spoke in the video, physics experiments, updates, and future plans. The thing that particularly jumped out to me was the result of your first experiment. That one lump isn't a particle pattern. That one lump is two interference patterns. That
Mm-hmm.
was a fascinating thing, and you went into a good interpretation of that, yours, and you stated that now not all scientists would come to this conclusion or this interpretation.
Mm-hmm.
Is there really a logical reason for this, or
Mm-hmm.
is the experiment itself or the information itself that you're getting from those two interference patterns logical in and of itself?
Yeah, yeah, to be honest about it, yes. I think it's perfectly clear, and the only logical result that you could have if you're being logical and rational is that that is not a particle pattern. That is two out of phase wave patterns. It's exactly what it is. I mean, the physicists that don't want to agree with that, they look at it and they see those two out of phase wave patterns. They see them there. It's perfectly clear. It's not like I'm the only one that's seen that. That's a standard result of those experiments. But it serves their purpose and their theory, particularly their theory about entanglement, to have that be a particle pattern. And if it's not a particle pattern, then there's a problem with their theory. They have a logical fault. So to them, it's just obvious to call that a particle pattern, and their theory is correct. So they just choose it that way, state it that way, and unless somebody takes them to court, so to speak, they can just let it be like that and get away with it. So yes, I think they're perfectly aware that there are two interference patterns underneath that create it. They will say that. They'll admit that. That's not like they don't admit that. But they turn around and call it a particle pattern anyway because it's a lump and it looks like one, and that suits their needs. So it's not something they particularly... So you could point that out to them. Yes, but look, there's two interference patterns in there. And they'd say, yes, there are. They wouldn't disagree with that. They maintain that it was a particle pattern just the same.
Is it true, Tom, that the way you had to do that experiment was not the way you designed it with a single photon, but you had to use the entangled pairs
Yeah.
in order to produce that because you don't
Yes.
have the equipment to fire a single photon?
Yes.
Why
It's
do
not
you
that I
think?
don't have it. Science doesn't have it. It's not available to just measure which way data without in any way, interfering with the result. So that's the problem. It just isn't physically possible to do that experiment yet. And maybe it will be
Yes.
one day. And whenever you start adding polarizers and entangled pairs like we did, then those artifacts that you add, the entangled pairs and the polarizers, will affect the result. They color the result. That's why there was two of those interference patterns that were out of phase with each other, because that is what the experiment does when you set it up that way. If it had done the way I wanted it to be done in the first place, that was impossible to do, you wouldn't have had those problems, and it would have been a very direct answer. So,
But the
yeah,
scientists at Copenhagen knew that the way that you would set up the single photon, they knew that that was a very startling result. They were very excited about that result, but that was a thought experiment that they didn't perform, and yet they knew that the results were significant of it.
mm-hmm. Yeah,
Yeah.
there had there's been double slit experiments going on for a long time, but they haven't really been perfect experiments. They always had little issues, and people always would pick on those issues as reasons for this or for that. So when they finally did it with entangled pairs, that was a big leap forward. And they did get better data than they had before, and they did show some things that were really important to show. It was a very brilliant experiment, and it did a lot of good. It was very good physics, but it didn't do everything. It did a lot, but it didn't do everything. And it left them with this idea of, well, not only it, but other things also, kind of pushed them in this idea that everything's entangled with everything, and that the information cannot be destroyed, and that information is out there someplace, available if you only had enough money to find it. Well, that's kind of silly too. It's not available. It's beyond reach, period. It's not, okay, you could say theoretically it's available. Well, that doesn't make it available. It's not actually available, and that's what it needs to be. So they just have this idea, and I think it's wrong. And this particular thing, if you look at it, it's perfectly obvious that there's two interference patterns in that lump, and that's where that lump comes from. And physicists do not disagree with that. They would agree with me. Yes, those two interference patterns made that lump. But they have to keep their theory going, and they just say, well, no matter how it got there, it's a lump, just like a particle pattern, so that's what we'll call it. That's my opinion. Maybe another physicist would take me to task for that, but that's the way it seems to me. That first entangled pair experiment, Sully et al., they ended up with the same thing. They ended up with a particle pattern that was created by two out-of-phase interference patterns. Now, they still used entangled particles. They didn't use polarizers to separate the two. Instead, they used some clever arrangements with mirrors and half-silvered mirrors. So they had it such that there was two ways that a particle could end up in this detector, and two ways that a particle could end up in that detector. And when they put all that stuff together, then they found out that, all the possibilities were covered. Every possibility, the way it could come, is there. And it always turned out that there were two out-of-phase interference patterns there, and they together make a single lump. But then saying that means that's a lump pattern, a particle pattern, that's wrong. It's not a particle pattern. There's two possible ways you can get there. So it's like you can get to this point through path A or through path B. And if you get to it two different ways, the difference between those paths is pi. One's going to be out of phase with the other. And that's just the nature of doing it. In this case, when you transmit, if you go through a piece of glass and you transmit, there's no phase change. If you reflect, there's a pi phase change. So one way to get into this thing is to transmit coming from this direction. The other way to get into it is to transmit or do the opposite thing coming from the other direction. And it's just the way it sets up. So I don't know that there's a rule that says there will always have to be two pairs with pi phase between them, but it seems that way. These experiments were done very differently, and it turns out with the exact same result. So I think you have an entangled pair. You have two slits. It goes through slit A or slit B. You have two paths. And each one of those paths can work its way into the various detectors. And when you get to where you erase the pathway data, so you expect to get an interference pattern, well, you do that. You can get an interference pattern, but each one separately gives you an interference pattern, but each path, there's a separation by pi. So I think we're stuck with that. That's just seems to be the way it is. But I think it was interesting that I pointed out to them clearly that calling that a particle pattern is just wrong. It serves to support their theory, but I think it's just wrong. It is not a particle pattern. It was not formed by a bunch of particles going straight and landing there. It was formed by two interference patterns. We'll just let that rest. There's not too much more you can do about that.
Well, it's so interesting. It really caught my attention, and I'm just total layperson. That was interesting to me. That is what you predicted, and that was actually there. Fascinating. Thank you. You have more power than you think. Hi, this is Donna from MBT Events. I have had the privilege to work with Tom Campbell for nearly 20 years now, and I can tell you from the feedback received through all those years that he has improved and changed thousands of lives with his My Big Toe theory. As a physicist and explorer of the larger reality, Tom has developed a program where you can learn to access and develop your natural ability as consciousness. His expertly crafted binaural beats are included. Details are in the description below. Thank you.
I and MBT Events hope you like this video. If you do, then you should consider being a Patreon member, because Patreon members get early access to our special content. You will also be able to get your questions answered by me in special Q&A sessions, and most importantly, your contribution as a patron member will enable us to produce the content that you're looking for. So thank you.